Hello all. In today's lecture, we will see Dirac's delta function, which is also known as impulse function. Dirac delta functions are used to represent impulses. Now what are impulses? Impulses are force that act for a very short time. For example, hammering a nail. During hammering a nail, the hammer strikes the nail for a very short time, but its magnitude is very high. Similarly, sudden voltage spike in an electric circuit can be another example, or airbag deployed in a car crash. That can be another example of an impulse. So in all these cases, a large amount of force acts for a very short time. This is called impulse, and to represent impulse, we take help of Dirac's delta function. Now, to represent Dirac delta functions mathematically, it is represented using delta t minus a. That means the function is active only at time equal to a, and at that time its magnitude is very high. So we represent as delta t minus a is equals to infinite at t equal to a and 0 otherwise. Now there are some properties of Dirac delta functions. The first property is, if we integrate Dirac delta function from minus infinity to infinity with respect to dt, we will get 1. And another property, the integration from minus infinity to infinity of a function ft multiplied by delta t minus a will give the value of this function at t equals to a. Next is Laplace transform of Dirac delta function. So the Laplace transform of Dirac delta function delta t minus a is equals to e to the power minus as. And the Laplace transform of Dirac delta function delta t minus a multiplied by function ft will give you f of a into e to the power minus as. Let's see one question. Here we have an initial value problem, y double dash plus 9y equals to delta t minus pi by 2 with initial condition y0 equals to 2 and y dash 0 equals to 0. So for this question, the first step is to take Laplace transform on both the side. So it will be Laplace transform of y double dash plus Laplace transform of 9y equals to Laplace transform of delta t minus pi by 2. Now Laplace transform of y double dash will be s square y minus s into y of 0 minus y dash 0 plus Laplace transform of 9y will be 9 capital Y, and Laplace transform of delta t minus pi by 2 will be e to the power minus as. A is pi by 2. So from here we will get s square y, y0 is 2, so it will be 2s, and y dash 0 is 0 plus 9y equals to e to the power minus pi by 2s. S square y plus 9y equals to e to the power minus pi by 2s plus 2s. So s square plus 9y equals to e to the power minus pi by 2s plus 2s. So y will be e to the power minus pi by 2s into 1 upon s square plus 9 plus 2s upon s square plus 9. Now we get capital Y, that is y as a function of s. From here we have to get y as a function of t, so we will take Laplace inverse So y will become Laplace inverse of e to the power minus pi by 2s into 1 upon s square plus 9 plus Laplace inverse of 2s upon s square plus 9. Now here we will use the property of unit step function, that is the Laplace of f of t minus a into unit step ut minus a is equals to Laplace of f of t into e to the power minus as, and the inverse of this will be inverse of fs into e to the power minus as will be f of t minus a into ut minus a. So in our first expression we have to find the Laplace inverse of 1 upon s square plus 9, and since e to the power minus pi by 2 s is multiplied, we can shift the time by pi by 2 and multiply with unit step. So first we have to find the Laplace inverse of 1 upon s square plus 9 into e to the power minus pi by 2s. Here we can multiply by 3 and divide by 3. So the Laplace inverse of this term will become sine 3t, and since e to the power minus pi by 2s is multiplied, time will be shifted by pi by 2 and 1 by 3. For the second term, Laplace inverse of 2s upon s square plus 9, and here u t minus pi by 2 also. Let's see another question. We have y double dash plus 4y equals to delta t minus pi minus delta t minus 2 pi, with initial condition as y0 equals to 0 and y dash 0 equals to 1. So again we will take Laplace transform on both the side. Now Laplace transform of y double dash will be s square into Laplace of y minus s into y of 0 minus y dash 0 plus 4 into Laplace of y, and the Laplace of delta t minus pi will be e to the power minus as, and Laplace of delta t minus 2 pi will be e to the power as. From here y0 is 0, so this term will be cancelled. So s square y minus 1 plus 4y equals to e to the power minus pi s minus e to the power minus 2 pi s. From here we will get y as e to the power minus pi s minus e to the power minus 2 pi s plus 1 upon s square plus 4. Now again from y we have to get y as a function of t, so we will take Laplace inverse in the next step. Before that we will split up the terms, so it will become e to the power minus pi s upon s square plus 4 minus e to the power minus 2 pi s upon s square plus 4 plus 1 upon s square plus 4. So y as a function of t will be Laplace inverse of e to the power minus pi s upon s square plus 4 minus Laplace inverse of e to the power minus 2 pi s upon s square plus 4 plus Laplace inverse of 1 upon s square plus 4. For the first term, we can multiply by 2 and divide by 2. So it will become 1 by 2 sine 2t with shifted t into u t minus pi. For the second term, it will be, we can multiply by 2 and divide by 2. So it will become 1 by 2 times sine 2 t minus 2 pi into u t minus 2 pi. And for the third term, we can multiply by 2 and divide by 2 again, and it will become 1 by 2 times sine 2t. So this will be the answer. Now for the second term, that is 2s upon s square plus 9, this will be 2 times cos of 3t. So our y will become 1 by 3 sine 3 t minus pi by 2 into u t minus pi by 2 plus 2 cos 3t. This will be the answer.